My name is Teacher Martin, and today we're going to look at a question of waves. As you can see in the diagram, you are seeing a transverse wave. So the question reads, Figure 10 shows a displacement distance graph. So we have the y-axis taking the displacement, and this displacement is the displacement of the particles by this transverse wave. And remember, a transverse wave is a wave in which the direction of wave travel is in perpendicular to the displacement of particles. So the particles of a transverse wave are displaced perpendicular. So we have this is the distance, and the distance is in meters, and the first part of the question was to in the diagram you show the wavelength. So the wavelength from definition is the distance between two crests or two troughs. So we can say it is between this point and this point, but also we can say it's between this point and this point. So where the wave starts and where the wave ends, one oscillation. So the distance is the wavelength. So in this case we have the first point as 20 Mach and the second point as 40 Mach. So the wavelength is the distance between this 20 Mach and 40 Mach, or it can be the distance between the 30 Mach and the 50 Mach, or the 10 and the 30 Mach. So that is the wavelength of this wave. So, and also the second part of the question, you are asked to determine the amplitude of that wave. Now the amplitude from this question, from the diagram, is the maximum displacement of the particles. Now the particles are displaced from this point to the topmost part. Now the topmost part where the particles are displaced maximally is the amplitude. So our amplitude is 10 meters. So the amplitude is basically 10 meters. As you can see, the amplitude is the maximum displacement of a wave, and it is 10 meters. I will ask the wavelength. The wavelength is the distance between two troughs and the crests. That is for transverse wave, or compressions, or distance between two compressions or rarefactions, and that is for longitudinal wave. And as we saw from our question is 50 minus 30, you can see this one. So we said we can have it at 20 and 40, we subtract is 20, or we can have it as 50 and 30 Mach. So the distance between this point and this point is the wavelength. So the wavelength is 50 meters minus 30 meters, and you get 20 meters. So the wavelength is 20 meters. Given that the frequency of the wave is 50 hertz, determine the period. Now the period of a wave, is the time taken for one complete oscillation, and it's given by 1 divided by the frequency. So the period is 1 divided by frequency, and remember the frequency is 50 hertz and our period is 0.2 hertz. Thank you for watching this video. I hope you will subscribe and comment, and also make sure you watch our previous video so that you can be able to understand the physics concept.